Okay, this video is about finding the zeros of polynomials, and these zeros can be either real or complex. Now let's just make sure we remind ourselves. Let me just put a polynomial up here. 2x cubed plus 3x squared minus 8x plus 3. The number of zeros in a polynomial is based on the degree being the largest exponent, which in this case is 3. So there are 3 zeros in this polynomial, meaning we cross the x-axis where the equation, if we were to set it equal to 0, would have 3 solutions. The real zeros, the rational zeros, if you graph this, you'll see them on your calculator. Imaginary zeros you don't see. And they're comprised of complex numbers, and we'll do an example of each. But the general question is typically going to be find the zeros. So the first thing you do is you look and determine what are the zeros, or what's the first zero that you can work with. And you check first to see if you can factor this or use other algebraic methods, and you can't. There's no way to factor this equation to start whittling down to find your zeros. We know the possible zeros are going to be plus or minus 1, plus or minus 3, over plus or minus 1, or plus or minus 2. That's because we can take the factors of the constant divided by the factors of the leading coefficient, and that gives us every combination that could be a zero. So it could be 1, 3, 3 over 2, negative 3 over 2, a half. Rather than have you test every possible zero to find one that's real, I've said you can use your calculator to pull off the first zero. So you'll graph this on your calculator, and if you graph it, you'll find that 1, at x equals 1, we have a 0. So we'll use that, and we'll go ahead and synthetically divide with the 0 you pulled off your calculator. And you should always get a remainder of 0 whenever you are synthetically dividing by a 0, which happened here. That's good. So that means x equals 1. The one you pulled off your calculator was valid. What that leaves us with is 2x squared plus 5x minus 3. Now you say to yourself, can you factor that or use quadratic formula to get the other 2 zeros? And anytime you get to a quadratic, the answer to that question is going to be yes. This is factorable. Two numbers that multiply to negative 6 and add to positive 5. Okay, so we go ahead and factor, which everybody knows how to do. And we get 2x minus 1 and x plus 3. So your other 2 zeros are a half and negative 3. So if the question is what are the zeros, you'll write 1, half, and negative 3. If the question is what are the factors of this polynomial, or what's the factorization look like, you'll write this. Meaning that if you multiply these 3 together, you'll end up with this original. Right, so that's one case where this is 3 real zeros. All 3 of these will appear on your calculator. And you needed to go to the calculator for the first 0 and the second 2 zeros you were able to find algebraically. Let me give you another problem. F of x equals x to the 4th minus 3x cubed plus 6x squared plus 2x minus 60. Now you've seen this one before, but let me just go through the steps here. This is an x to the 4th. I'm actually going to tell you that 1 plus 3i is one of the factors. So the first thing I told you in class was anytime you have a complex 0, the conjugate is also, the complex conjugate is also a 0. So there's 4 zeros in this polynomial. I gave you the first one. You can determine the second one just by virtue of the fact that if 1 plus 3i is 0, 1 minus 3i also has to be 0. Now you have 2 of them. What I've suggested is rather than synthetically dividing with these imaginary numbers here, that the easier thing to do would be to do the following. It would be to convert each of these zeros into factored form And remember, factored form, just like here, when 1 was 0, x minus 1 is the factor. When 1 plus 3i is the 0, x minus 1 plus 3i is the factor. Let me distribute the negative. Okay, all I did was distribute the negative. Here are my two factors. We multiply these factors together. X minus 1 minus 3i, x minus 1 plus 3i. Now you might say that's a lot of multiplication. It's 3 by 3. But what you can do is you can see that we can rewrite this as an a minus b and an a plus b. Right? Where a is x minus 1 and b equals 3i. Pattern here. And we know that a minus b times a plus b is a squared minus b squared. So I'll do a squared minus b squared. I'll FOIL that out. And I get x squared minus 2x plus 10. So the multiplication of these two factors, this times this, yields this. Okay, the next step, I'm going to take that result and I'm going to long divide it into the original. Now I'm not going to go ahead and run that long division here, because you all know how to long divide. But when you do that long division, you wind up getting x squared minus x minus 6. And it's this answer of x squared minus x minus 6 that provides for you the last two zeros. We factor that, and we have x equals 3 and x equals negative 2. So what are the four zeros? The four zeros are 1 plus 3i, and that was given. 1 minus 3i, because it's the complex conjugate. And then the real zeros, or the rationals, are 3 and negative 2. So those are your four zeros for that particular polynomial. So that's how, those are the two types of problems. Factorable, use your non-complex, and then there's the complex type where you have to multiply the factors to get to the answer using this method here. So good luck with that.